Okay. So, please also remember to, okay, maybe I must start with good morning, everyone. Please remember to complete the register, which will be in the chat. Let me quickly see if I posted it now on the chat. Just copy the links again and repost them on the chat. And yeah, and then at the end of the session, don't forget to complete the feedback form or the evaluation form. So welcome to this week's session. We will continue with discrete probabilities, but only focusing on the Poisson. And then we will move into today's session, which covers the normal probabilities. So Poisson, like I said, we will still need to be using the table, formulas, as well as you need the calculator to calculate the probabilities. So what is a Poisson probability? A Poisson distribution is when you are interested in the number of times an event occurs at a given opportunity, which means you will be calculating what we call an average, because it will be at, like, you can't be counting them individually like 1, 2, 3, 4, 5, as we know that discrete probabilities follows a counting process. So with Poisson as well, once you observe those moments or events happening, you will need to come up with an average of those number of times that those events are happening. So that will also enable you to calculate what we call an area of an opportunity, which that area of an opportunity is just the average of that time that you observed, or it will be either a volume or it might be a unit. So let's say, for example, the number of scratches on a car paint. Like, for example, if you are working in an insurance firm, you want to know how many of the cars that comes for repairs on average, they come with scratches. So you count how many of those and you can average it for that period, for that time period that they have been, like in an hourly or in a weekly or in a monthly or something like that. The number of mosquito bites on a person, so you can also count how many there are and average for each individual person that you saw for that week, for that month. You can count those average number of mosquito bites, and so on and so forth. So Poisson follows that pattern as well of a discrete distribution as well. With Poisson, also, there are some characteristics which we will be able to calculate the average, which is the mean of those. So it means taking the mean or the average of those number of times things happening, or we can calculate but the variance or your standard deviation. So with Poisson, the average that you get will be your mean, and your variance will be the average, and your standard deviation is the square root of your mean or your average. So it's fairly easy. So the average you receive is your mean. The mean is also equivalent to your variance. Your standard deviation is the square root of your average. Easy. If, for example, this is what we need to calculate. A local police station receives on average 3.5 emergency calls per hour. So they would have counted every hour. This had the number of emergency calls they receive, and they average it, and they find that every hour they receive around 3.5 calls. So those calls, they follow what we call a Poisson distribution. If the question asks, what is the mean of the number of calls that the police station receives, that is easy because on average, we know that it receives 3.5, so the mean will be equals to 3.5. Oh, my pen is not writing today. Just give me a second. Sometimes it needs me to activate it. Sorry, I should have prepared this. Yeah. It just needs to be waken up a bit. So it means the average is 3.5. And if they ask you what is the variance or the distance far apart from the mean, and that variance will be equals to the same as the average, which will be 3.5. And if they ask you what is the standard deviation, so the standard deviation will be the square root of your 3.5, which then will be equals to the square root of 3.5 will be equals to 1.9. 1.9. And that's how easy it is. Poisson is straightforward, easy, simple to calculate and find some of the characteristics of the what you call the parameters of the measures of Poisson distribution. Now, here is your exercise. Suppose that the number of daily fake news posts is a Poisson distributed with the mean of 0.2 per day. What is the value of the mean and the standard deviation? So which one, which option? Number 1, number 2, or number 3? So since we know that the mean is the same as your lambda, or it's your mu.
I think it's option number 1, ma'am.
So is that option number 1, because the mean, which will be in the Poisson, the mean is your lambda, and here they're asking you to calculate the mean and the standard deviation, and we know that the mean is the same as your average, and your standard deviation is the square root of your average. And then will be 0.2, and this will be the square root of 0.2, which is equals to 0.444, and we round it off to 1 decimal and only number 1. That's correct. Easy, né? So you won't forget to the properties of Poisson if they ask you to find the mean or the standard deviation. It's easy, easy, easy. When it comes to the probability, it's a different story. For a probability, then you need to calculate the probability of an event happening, which follows that average or the Poisson distribution. And the formula is calculated with the exponent to the power of the negative average times the average to the power of x divided by the x exclamation, which is factorial, x factorial. So like we did with binomial, distribution, the same can happen with Poisson. You can use the formula to calculate the probability of a Poisson distribution, or you can use the table. When you use the formula, please do not type in the number on your calculator. There is an e-base or a base natural log function, and it is it's written in orange if you're using a Casio calculator, or if you're using a Sharp or something, it's also going to be written in orange. It will be on top of the len function. So in order for you to reach that function, you will just press the shift button. The negative is not a minus. There is a negative that sits in the bracket. So you will have to use that negative sign. And like we did with the Poisson last week, with the binomial last week, the factorial, there is an x factorial or an n factorial, depending on which calculator you are using. You can just use those functions to calculate. Right. So how do we then calculate the probability of a Poisson? The other catch, or the other thing that we also need to remember are those mathematical functions, like less than or equal, greater than or equal, between, and so on. You need to know and still remember to apply those logic when you are calculating. So what does that mean? It means if I have to calculate the probability, if I need to calculate the probability that the mean average was greater than 1, where then it means I'm going to be calculating the probability that x is equals to 1 plus the probability that x is equals to 2 plus the probability that x is equals to 3 up until I get to whatever the number that I need to get to. What does that mean? It means this formula, you will have to apply it on each and every probability that you have. So you will repeat this formula for where it's 1, repeat this formula where it's 2, repeat this formula where it's 3. And it makes it easier with the table, because on the table, they give you the probability and that's it. So that is just what I wanted to explain in relation to this, because I remember that last week I didn't explain how then the formula it becomes so complex when it's a long formula that you need to do for each and every probability of an equal. So using a table, easy. So if I have to calculate the probability, let's assume that I'm going to be calculating the probability where x is equals to 2, where the lambda is equals to 0.5, right? So on the table, we will get to the table just now, but bear with me. I'm going to show you the actual table. But the table is broken down by lambda. So you will have multiple tables that are broken down by lambda from the value of x's that starts from 0 to whatever the number based on the lambda distribution. So the next table will start at 1.0 or something like that. And then it continues and continues, and the number of x will also will increase to 8 or 9 or 10. You just need to look at the average or the lambda value and then apply the x values based on that lambda value. So let's find the probability that x is equals to 2, given that our average is 0.5. So on the table, it's easy. We go and find the lambda where it's 0.5. And then we then go and look for where x is equals to 2, where the 2 meet. My sign is not on the right thing. The answer will be 0.0758. So easy to find the probability. If I need to use the calculator, and use the formula, so therefore it means I'm going to substitute. So E is a natural log, so you don't do anything to that. Our lambda is 0.5. We substitute that. And x is 2, so we make it to the power of 2, and this is 2. So on your Casio calculator, you can put, if you have a Casio calculator, you use your fraction formula and you put everything in, and the answer you will get, you will see it will give you the same as the table formula. So now let's do another activity. What if then, instead of saying the probability of x is equals to 2, what if they say the probability of x is less than 2? We still keep the average, the lambda, as 0.5. What does that mean? Then it means I need to find the probability of x less than 2 will be equals to the probability of x is equals to 0 plus the probability of x is equals to 1. Because it's less than, so it does not include 2. So I need to only take those probabilities for x of 0 and 1. So if I'm going to use the table, easy, because I just go to the table and add those two values. So I'm just going to add 0.6065 plus 0.3033. And that will give me the probability zero comma 6065 plus 0.3033, which is the probability will be equals to 0.9098. Easy. If I'm not using the table and I'm using the formula, still, I need to go and find the probability of x is equals to 1, which is equals to e to the power of negative 0.5 times 0.5 to the power of 1 divide by 1 factorial, which then on the calculator, let me see if I can get my Casio calculator online as well. Casio. Okay, I'm not gonna find it here. I will find it on my desktop, I guess. Then I need to go to the desktop. Sorry, my bad. Let's open it up. If I still have a license, and then I can show you and demo. I think my license expired. See? South Africa, where are you? Oh. Yeah, I need a new a new license. Activation failed. You have already reached the allowable. Yeah, no, I can't open my Casio license now. Oh, I don't have that. Okay, so I'll just have to use my phone or my calculator to do that. So anyway, it didn't allow me to, so let's do that. My fraction thing, shift e to the power of negative 0.5 and my arrow to the side, multiply by, or I can even use the bracket the way it's written, 0.5 to the power of 1, not to the power of 2, to the power of 1. My arrow down, and 1 shift factorial. And the answer I get is 0.3032653, which I can then just round it off to 3. As you can see, that it gives me the same as what we have. And now if I want to do for 0, I just change everywhere where it is 1, I replace the 1. So x is equals to 0. Therefore, it's e to the power of negative 0.5 times 0.5 to the power of 0 divided by 0 factorial. We know that anything to the power of of 0 is 1. And 0 factorial is 1. So we just need to calculate shift e to the power of negative 0.5, which is equals to 0, 0.6065306. So the number to the right of 5 is 3, so therefore it means it's 5. So it also gives me that. So I just add the same number and I will still get the same. So using the table can save you time, but also it's not always the solution, because sometimes in the exam you are expected to also know the formula so that you can answer any question. If they give you a formula that is incomplete or the formula that is completed, then they ask you for this question, choose the right formula. You need to be able to know how to do that. And we're going to see it in the activity. So I'm just going to skip all of those and then come to this so that I can demonstrate the importance of also knowing the two methods. It's not like I'm saying only learn how to use the formula or use the table. I'm saying learn both. The table saves you time in the exam where it's time constrained, and knowing the formula helps you to answer questions that are relevant to the Poisson distribution. So let's look at this question. It says, the average number of adults with ASD consulting with a neuropsychologist per day is Poisson distributed with the average of 1.5. So it means we know that our lambda is 1.5. What is the probability that on a given day, a neuropsychologist will consult with only 1? Therefore, it means it's equals to, because it's not saying greater than, it's not saying less than, or it's not saying more than, or at least, or any of those. It says will consult with only 1. Therefore, it means it will be, we need to find the probability that x is equals to 1. What is the answer? Is it option 1, option 2, option 4, or option 5? Oh, I forgot. Before you get to option 1, option 2, or option 3, let me also do this. So on the tables, there is a table called Poisson distribution table. It's table E, should be after the binomial, table E7. As you can see, it's broken down by the lambdas. So you can see that for a table that starts with lambda of 0.1 to 1, it's up to 7. But the table with lambda from 1.1 to 2, runs up until 9, and so on and so forth. You can see there. So it means if I have to calculate the probability of a greater than 3, and the average is 0.6, therefore it means I must add up until 7. But if I'm on 1.5 and I have to do greater than 3, therefore it means I must do up until 9, and so on and so forth. So using the table, we can quickly find the answer we are looking for. So we're looking at 0. Let me make the table smaller again. So we know that we are looking at this table because our average is 1.5. Right? So the process of elimination becomes easier. So you first go to the probability, or the average, which is 1.5. We know that we are using this table. Now we need x is equals to 1, and we go there where they meet. The answer is 0.3347. And you look at the answers you got here, it's none of those answers. So therefore it means they're asking you to check if the formula is correct. Right? So then we go and we complete the formula. So let's see if we'll get the same. X is equals to 1 will be given by e to the power of negative lambda to the power of x divided by x factorial. So then let's substitute. E to the power of negative lambda is 1.5, and your lambda is 1.5. So if I look at this formula, they are using a multiplication, so we can do that. 1.5 to the power of 1. We know anything to the power of 1, we don't have to necessarily put it up, right? Put to the power of 1, so we can leave it. And this will be 1 factorial. Or we can put it up anyway. So let's look at the formula. Does it relate? 1.5 to the power of 1, we've covered that, times e to the power of a negative 1.5 divided by 1 factorial. Therefore, that is the correct answer. As you can see, the table doesn't necessarily help you answer the question in quick, but it can help you save a lot of time, because you could have used the formula, calculated, and still not find the answer and then get there. Or you could have used the formula, substituted, and find the answer immediately. You'll never know how they asked the question. Are we good? Or do you want to practice more on the Poisson?
On my side, I'm good, man.
Cool. Now let's move to the next session. The continuous distribution. I didn't even check if we have more people joining the session. I can't see when I'm presenting. Let's see when I'm presenting. So, normal distribution. So by the end of the session, we should learn how to understand the basic concepts of normal distribution. What makes a normal distribution? The reason why also I know that these are the literacy sessions. We should be doing more of calculation, giving you tips and tricks, but also in the exam or in the assignment, they still ask you questions related to the content, like the basic concepts of normal distribution. They might ask you a question about what makes a distribution a normal distribution. So you need to know those properties. So that is why I also do share them with you, so that you can know what those are. You should also be able to learn and know how to calculate the probabilities of a normal distribution. Now, with the normal distribution, it will work slightly different to how we did it with the binomial and the Poisson and the discrete probabilities purely. Here, because with normal distribution, we are not working with a probability at the point. We are working with continuous normal distribution probabilities. So therefore, it means we're working with cumulative probabilities as opposed to working with a point probability, like with a discrete probability, where we can find the probability of equal to or less than or equals to. So with normal distribution, there are no point probabilities, are always cumulative probabilities. So we will deal with the probability slightly different. So you should be able to calculate the probability of a less than a value, a probability of a greater than a value, and a probability that a value sits between two values. And also use the formulas. So we will have to calculate this Z value because we're not calculating a probability of an X value, but we need to standardize the X value so that we can use that standardized value to find the probability. And I'm just going to explain that. That's why I said it's very different. So a continuous random variable is a variable that can assume any value on a continuum, and it can assume an unaccountable number of values because we are looking at cumulative value. Like, for example, the thickness of a item, because if you look at some items that are shaped like they are thin, and then they become bulky. So the thickness, if you continue with looking at, let's say, a bottle, a juice bottle, you can clearly see that it doesn't have the same thickness across from the bottle top to the bottom top anyway. So those are the things that we look at when we look at continuous. So the continuity of how things appear, the time required to complete the task. So it might slightly differ, it might take longer, and then the more you know about how to do it, it becomes shorter and shorter and that. The temperature of a solution, in the beginning it becomes hot, and then as it stands it becomes cold and colder. So it doesn't stay static, as in like it will always be 100 degrees throughout. All right. The height in inches and so on and so forth. This can be potentially taken on any value depending on the ability or the precise or the accuracy of that measure that you are using. So it means when we look at normal distribution, you can have the distribution follow a different format. And those formats are based on two measure or parameters. We can call them parameters because at the beginning of the sessions, like at the beginning of the units, you learned about the difference between a sample and a parameter. Oh, sorry, a statistics and a parameter. And here we are basing the normal distribution on a parameter because we're looking at the population of interest. So the shape of your normal distribution depends on two things, on the mean and the standard deviation. So varying the different means will give you a different shape of your normal distribution. If you vary your standard deviation, it will also give you the different shapes. So for example, if I look at the pink distribution, and Also, the normal distribution is also called the belly-shaped curve, and we're going to talk about it just now. If you look at the pink distribution, there clearly you can see that it has the standard deviations are wider, because in the middle of every standard deviation is your mean, of your normal distribution is your mean, and the distance between the mean and the end of your standard deviation, the end of your distribution, is what we call the standard deviation. So this is your standard deviation. So looking at the pink distribution, you can see that the distance between the mean and the edge of your distribution is bigger. So it means the standard deviation there is big. So this one has a bigger standard deviation, and it forms a flat belly. So the bigger the standard deviation, the flatter the normal distribution will be. If I look at the yellow and the turquoise, I don't know whether it's turquoise or what, this color, the blue color, you can see that clearly they've got the same mean, almost. They have the same mean. What is different between the two is your standard deviation. So the standard deviation for the yellow and the standard deviation for the turquoise are different. So what does that mean? It means the smaller your standard deviation, the peaker your distribution will be. Uh, so if your standard deviation is smaller, then your peak of your graph will be too large, so it will be taller. And if it's normal, like 1.5 standard deviation away from the mean, and then it forms a normal distribution. So the shape looks much better, and it looks what we call normal. Not that the others are not normal, they are normal, but they've got narrow and also flatter shape depending on your mean and your standard deviation. So if you move the value of your mean, it shifts your maybe I'm also talking ahead of time. So the more when you move the mean, it moves your distribution from left to right. So depending, so if you move your mean, if your mean now comes here, so it means your graph will move to the left. If your mean moves here, then it means your graph will move to the right. Your standard deviation increases the spread. So it tells you whether if your standard deviation is smaller, it will be flatter. If it's bigger, if it's bigger, it becomes flatter, and if it's smaller, it becomes taller, like we said it. So it means the changing or the increase and the decrease of your standard deviation will change the spread of your distribution. The change or the shift in your mean will move your distribution from left to right. So those are the basic things that you always need to remember, how the mean and the standard deviation influences how your normal distribution shape will look like. So what then do we do? So if, for example, I've got observations like our X observation, at any point that I am taking, and I record and monitor those observations over a period, I need to, in order for me to find out whether they follow a normal distribution, I need to be able to standardize those points. So that is why we talk about a standardized normal distribution. So any normal distribution with the mean and the standard deviation can be transformed into a standardized normal distribution where we use the value of a z. And we're going to talk about that z, and we call those z values we're going to call them z-scores or z-values. So a standardized normal distribution always has the mean of 0. Also, it means the mean will always be equals to 0 and the standard deviation of 1. So that is the property of a normal distribution. So if you have a distribution that has the mean of 0 and the standard deviation of 1, you can safely say that is a standardized normal distribution. So we're going to transform our x units, which are our x values, into our z unit. And we're going to use those z units to calculate the probability of those x units that we want. So a normal distribution, like I said, it's a belly-shaped curve and it's symmetric. What does symmetric mean? We did this in study unit 3. We said if the mean, the median, and the mode are equal, then it means the distribution is symmetric. So it's when the mean and the median are equal. In order for us to standardize the unit, we then use this formula, which is the Z formula or the Z-score formula, which is your X unit minus the population mean divided by the standard deviation. And we always remember and know that for a standardized normal distribution, the mean is equals to 0 and the standard deviation is equal to 1. That does not mean in this formula we're going to put there the mean 0 and the standard deviation 0 and standard deviation 1. It just means for this Z distribution, we are making sure that the mean is equals to 0 and the standard deviation is equals to 1. Therefore, it means we will have to know the population mean that we want to standardize and the population standard deviation, which will be the values that we substitute, and we need the X value that we are given, what that we need to standardize. Okay? So let's look at this example. If X is normally distributed with the mean of 100 and the standard deviation of 50, find the Z value for where X is equals to 200. So they have given us the mean, which is the mu, and the standard deviation, which is our sigma of 50. We just go to our Z formula and we substitute into that Z formula. So X is 200, mean is 100 divided by our standard deviation of 50, and then we get the Z units of 2 or our Z score of 2. Therefore, it means for X of 200, it is 2 standard deviation away from the mean of 100. So there are 2 increments. So if I have to draw that, I don't know how to draw properly. The other thing that you also need to notice when you draw your normal distribution, the line at the bottom does not always have to touch the distribution. So it's always almost, it doesn't touch, they don't touch. So they always do that. So we say we had this, we know that this is the mean. So if this is 1 and this is 2, so what does that mean? It means from here to here on this example that we are given, the distance between the mean and the edge is only just 2 standard deviation, 2 increments of 50. So if then it means this was 50 and this was 50, which makes it 2 standard deviation away from the mean. So that is what, in a nutshell, practical, that means. Let's look at an exercise so that you can practice. For a particular group of scores, the population mean and the standard deviation are 25 and 5 respectively. So it means this is your mean and this is your standard deviation. Find the z-score for this row score. So it means they're saying use the formula x minus the mean divided by the standard deviation and find what the z-score is. Where the row score is 19, so this is your x. Is it A, B, C, D, or E?
It is C, ma'am. I can't see
It's
negative 1.2.
negative 1.2 because we know that our x is 19 minus our population mean of 25 divided by our standard deviation of 5, which is negative 1.2. So when we are moving forward into the probabilities, there are a couple of things I need to remind you. So when we calculate the z-score and we find that the value of a z-score is equals to a negative 1.2, we keep it as is, but we also going to say your z-score will be negative 1.20. We always keep it to 2 decimal, and I'm going to explain this shortly just now when we deal with the tables and finding the probabilities. So having a negative number, it's very important because on the tables, we are going to use the normal distribution tables has the negative and the positive side of the table. So that is very important. But also the Z tables has 2 decimal at the top. So we always have to keep the values into 2 decimals. But for this exercise, we look at what the answer would be and we just keep it at that. So it means very important, you need to know how to round off properly. So remember, if I'm rounding off to 2 decimal, I must look at the number from the 2 decimal to the left of it. So sorry, to the right of it. If it's greater than or equals to 5, I must add 1. If it's not, then I must leave it as is. So you need those principles needs to remain. Because the minute you add another number, you're increasing the probability numbers. If you don't include or if you don't round off properly, you are missing out on one of those probabilities because you will get the wrong answer. So it's very important that you know how to round off properly. Okay, so this is one of those questions that I said, or one of those things that I said. You also need to know and understand the basic properties that make up a normal distribution. It's very important. Knowing how to calculate is also very important, but also knowing the basic properties of a distribution can also be a breaking point for you to pass or fail a module. So you need to know this. So which one of the following statement is incorrect with regards to the normal distribution? So we're going to go through option by option and eliminate, do an elimination process. So we need to find the one that is incorrect. So I'm going to read option 1. The z-score of a mean of a normal distribution is 1. The z-score of a mean of a normal distribution is 1. Number 2, the smaller the value of a standard deviation, the narrow and the steeper the curve. Number 3, the mean of a normal distribution can be a numerical value, that is a negative, a 0, or a positive. The area to the right of the mean of a standard deviation is 0.5, and the area to the left of the mean of the normal standard deviation is 0.5. 95.4% of the values of a normal distribution variable are within 2 plus or minus 2 standard deviation of the mean. What did I not do to you is the following. I've never explained that, so it means I expect you to say, you know how to get to that. I have never explained that, so it means you need to know where in the what do you call it? In the study guide, where to find that information. What else didn't I explain? I didn't explain that. So as you can see, most of these things I didn't even touch in my explanation of the basic probabilities. And they expect you to know how to respond to those. What else didn't I not touch? The only thing I touched in our conversations is that one. So if we need to find the incorrect statement, we then need to do a process of an elimination based on what we also know. I don't know if you want to give it a try. Before you also give it a try, what I didn't explain around this 94, which is 2 standard deviation, is the following. There is what we call an empirical rule. Empirical rule, which states that you need to calculate from both sides the mean plus or minus the 3 standard deviation, and it will give you where it is. And that it is always 99.7%. The mean plus or minus 2 standard deviation is 90. I'm just going to give you the answers for this one. It's always 95.4%. And let me write it at the top. Then the mean plus 1 standard deviation is always 68%. So it means in this instance, number number 5 is correct. What I didn't also explain is number 4. What does number 4 mean? So we said, now I'm drawing a skewed. If think about this as something that is perfectly drawn, it's not skewed to one side. Since I don't know how to draw properly. So if we split this into two, this side should be 50% to this side. Why? What did we say about the probabilities? We said the sum of all probabilities. We did this at in study unit 4. The sum of all probabilities should always be equals to 1. And what does that mean? It is always equals to 100%. So if I split my normal distribution into two parts, what does that mean? It means I'm dividing the 100% into two. So it means what? 50-50. So the area to the left will be 50% and the area to the right will be 50%. That's what number 4 says. So done. We covered that part. We know that it is correct. Moving on to the next one, which is what are we covering in the next one? It says, oh, the mean. The mean of a normal distribution can be any numerical value, whether it's a negative, a 0, or a positive value. So if I'm talking about the normal distribution, and I say my mean here represent a 0. So my mean there is 0. Therefore, it means if my mean comes to this side, it will be equals to a negative because this side there are positive. So what does that mean? That does mean my statement number 3 is correct? Definitely, because if my mean is 0 there, any value, any mean value on the left of that 0 will be a negative mean. Any value on the right of that 0 will be a positive value. So therefore, it means statement number 3 stands correct. Then leaves me with the 2. What are the 2? Number 2, or do we go with number 1? Oh, let's do number 2 because we covered number 2 just now, not so long ago. What did we say? We said, if I go back 2, 3 slides back, there we go. We said if we change the mean, it becomes there. If the, what do you call that now? We said the standard deviation increases the spread. Oh, actually, we can use this. This is the most important one. We can use this. The question there said it's steeper when the standard deviation is smaller, or it's flatter when the standard deviation is bigger. So let's go back. What does that mean in this statement? The smaller the value of your standard deviation, the narrow and steeper your curve will be. What does that mean? So if I have the mean here, so it means my standard deviation will be smaller. So if I have my mean here and oh no, it cannot be bigger like that. It will have to be like that. So the mean is there and my standard deviation is there. So it means the larger the standard deviation, it becomes wider. So large, how do we write it? Large standard deviation is wider and flatter, whereas smaller will be narrow and steeper. So what is left for us to evaluate and make sure that it's correct is the first one. The z-score of a mean of a normal distribution is 1. It's not, because let's go there. We calculated the z-score of a normal distribution. Did we find it as 1? Nope. Did we find it? It can take any range. It can take any form of a value, whether a negative value or a positive value. So it is not 1. And also, one other thing, what does the mean of a Z distribution? It's always 0. So if the distribution can take any value, but the mean of that Z distribution is always equals to 0. That's what we said. Huh? Only the standard deviation is equals to 1. Go back. The z-score mean, because I only used that in my explanation here, because that's the z-score. It can take any value, but the questions say the mean of a normal distribution of that. We know that the mean is always equals to 0, because we said it in the properties. The mean is always equals to 0, and the standard deviation is equals to 1. So in this instance, 1 is the one that is incorrect. So 1 is incorrect. So you need to know and remember all of those. What also I didn't cover is, let me see. So I've covered the empirical rule, which I forgot to show you. What I will do on WhatsApp, I will share with you a summary fact sheet that I created. You will see all this from point 1 until point 5. I'm covering all of them. So the z-score mean of a normal distribution is equals to 0, and the z is equals to 1 standard deviation above from the mean, and a -1 standard deviation below the mean, and so on and so forth. I think that will help with that explanation. The other thing that you will get will be the the empirical rule. Now, here is the most important thing that we always need to remember with the empirical rule as well. Sometimes they might ask you to calculate them. They might ask you to calculate 2 standard deviation, 3 standard deviations, and so on and so forth. You should be able to just substitute. If they give you the mean and the standard deviation, you should be able to just substitute and calculate them as well. Right? So that is that. Now let's move on to the next part, the most exciting part, which is how do we then find the probabilities themselves of a normal distribution? What does that mean? We want to find the area underneath the curve. So if I need to find the probability of a Z value, so now we standardized our X values and we created this X unit. So let's assume that this line at the bottom represents the values of our Z unit. So if I'm saying what is the probability that a Z value will be less than A value? So I'm going to go and select where that Z value is. So if, for example, that Z value is 1.2, so therefore it means this is 1.2. So I want to know everything below, so everything from there going there, what is the probability of that area underneath? Now, here is the catch with everything. If you look at this, there is this small white unshaded area. We ignore that one unshaded area and we use the less than probability. Now, the table that we are going to be using, which is the standardized normal distribution table, contains only and only, like I'm stressing it, right? The probability of a Z-score value less than a value. If you need to find the probability of a greater than, then I will tell you and show you how to find that. So the table only contains these probabilities. So it means every time I calculate the probability of a less than a value, I will find that probability on the table. That's why I said how we calculate the probability will be different to how we calculate them using the binomial and the Poisson table. So we need to know how to use this table. So what is the table and how does it look? So let's first understand the table. So that will be the first table, which is table E2. So what does that mean? So it means table E2 contains all the probabilities that a Z value is less than a value. We need to remember that. So it means any question we get, find the probability that Z score is less than 3, is less than 3.00, is less than negative 3 point mama. It doesn't matter as long as less than. We will find that probability here. So then do we use this table? So the table contains the positive table. If your Z value was negative, you go to the negative side of the table, right? But our table has values at the top and the values on the side. How then does it calculate? So remember when we calculated the Z-score, I said to you, you need to always leave it to 2 decimal. So we're going to use our example of Z. Or now I'm going to change it to a less than because I need to use the table of negative 1.2, right? And I said, put a 0 at the end so that it is 2 decimals. Okay, now we're going to use this to find the probability. I need to go and find that probability of that Z-score. How then do I read it on the table? Easy. The first 2 numbers, the one before the comma and the one after the comma, you will find it on the side of the table. So it means on the side, I must look for negative 1.2. On the side of the table, I'm going to find the value before the comma and the value after the comma. So 1.2, I'll find it. The last digit, which is my second digit, I will find it at the top. So you can just ignore all the other numbers like 0.0 and only look at the last digit on this. So here our last digit is 0, so therefore it means our last digit will be on this one. Because you can see that it carries only the last digit and there is populated. Even when you go to the positive side, you will see that it's only the last digit that is populated at the top. So since our last digit here is 0, so it means I'm going to use the 0,00. Then I need to come here and look for 1,2 and there. So the answer here is 0,1151. Easy. That's how you find the probability of a less than a value. If the z-score that we found was, and let me just make up a number. So if we need to find the probability of z less than 3.12. Let me complicate things and put random numbers there. Find the probability that z is less than 3.2. The first thing I need to check is this is positive, so it means I must go to the positive side table. And I know that I'm looking for the probability that z is less than 3.12. So I write it there, and I need to find 3.1 because it's 3.12, right? The value before comma and the value after comma, I will find it here. And at the top, I must look for 2 and there. And it's column number 3. Therefore, it means that is the probability. 0.99910. And Bob is your uncle. That's how easy it is. Okay, so let's go back to our presentation. I've explained this. So your table has the positive and the negative side. Let's find the probability that let X represent the time it takes in seconds to download an image file from the internet. Suppose X is normally distributed with the mean of 18 seconds and the standard deviation of 5 seconds. Find the probability that X is less than 18.6. So we know now we need to go and find this because we need to standardize it. So we know normally this is if the mean is here, which is 18, our standard deviation is 0.5. So it means distance from here to there is 5. And they told us we need to find less than 18.6. So 18.6 will be somewhere here. So we then shade the entire area. So we need to find this area, the red area, because that's what we need. But we cannot just go and find it on the table. We need to standardize it. So it means we need to go and calculate the Z value for this. So we go and standardize. We use the Z formula, which then it's finding the Z of less than X minus the mean divided by the standard deviation, which is what we have there. I know that I'm using an equal sign because I'm just using the formula as is for the ease of calculation, but that is the same way. So therefore, it means we're going to find, if after I've calculated and substituted all the values, I find the Z value of less than 0,12. That is what I have, because I have to round it off to 2 decimal. Now, since I have this, I go to the Z table. It's positive, so it means I must be on the positive side of the table, right? So we standardized our units to a normal distribution, a standardized normal distribution. For some reason, my laptop is not charging. Just give me a second to fix it. Otherwise, it's gonna... Okay. So, oh, pen. The pen, it's the pen, not the Okay, so for now, I'm gonna explain without using the pen because it says the pen is running low, not the laptop. Okay. Okay, so now we know that we standardized this, right? We standardized it, and we now know that our Z value is on the Z line. We need to be finding this area. Where do we find this Z area value? On the Z table. So we go to the Z table. So here is my snippet of it. I have positive. I went to the positive side. I need 0.1 on the side, 0.1. At the top, I need only 2. And where they meet, that's where my standardized value would be. And this area from here to there, it's only 55%, which is 0.5478. And that is the probability of X less than 18.6. Easy. Let's do, I don't have an exercise. Now, I said I'm going to also explain what then happens if I need to find the probability of a greater than a value, because then the table does not have that. The table has the less than values. So now, if I have to find the probability of a Z standardized score of greater than a value, it means since the table has the greater than, and we know the sum of all probabilities should always be equals to 1, therefore it means I can subtract the less than probability and get the greater probability. Because at the end of the day, in a nutshell, if you think about it, probabilities are easy to do. We know that the probability of Z less than a value plus the probability of Z greater than or equals to a value. At this point, I'm just going to use the both side, will be equals to 1, because this does not include A, this includes A, right? So both of them, if I add them together, they will give me 1. They should always give me 1. Needs to be collectively exhaustive. So it means, and mutually exclusive. So it means if I add all of them, they should always give me a value of 1. So I know that this value I can find on the table, but I don't have this value. So how do I find this value? Then to find the probability, and because we don't use the probability at the point, we just convert our probability to a greater than A value, even though we know that it might not cover all of them, but with normal distribution, we assume that we are covering all of them, minus, we take this on the other side, we will find the probability of Z less than A. So we've got our collectively exhaustive probability covered. So that is why every time you will have to find the probability of a greater than, you just say 1 minus the probability of a value you see on the table. Right? Easy. For every time you need to calculate the probability of a greater than, it will be 1 minus the value you see on the table. Okay, how then do we do it? So we're going to use the same exercise we did. So we know that we need to standardize this X value of 18.6. Our mean is 18. Our standard deviation is 5. So we go and calculate the standard deviation. We did calculate the Z score, right? We know that it was 0.12. We calculated it previously. So we just say 1 minus the probability of the value we're going to find on the table. And we know that the probability of the value we found on the table, we did find it because I'm using the same data. I didn't change anything. I just changed the sign. So we found it. It was 0.5478, and that's what I'm using there. You just say 1 minus that, and it gives you the remainder. Because this shaded area in blue is what we calculated previously on the probability of a less than, and the red is the probability of a greater than. And the right or the left figure, I'm just showing you that both the blue and the red, when you combine them, they give you 1. So if I add 0.5478 and 0.5422, it will give me 1. That's that. That's the probability of a normal distribution. It's easy as that. Do you need to know and remember the graphs I'm drawing? No, not necessarily. The only thing that matters is remembering the formulas. Remembering that when it's greater than, it's 1 minus the table value. When it's less than, it is the table value. That's it. That's how easy it is. Simple, straightforward, easy to find the probability of a value, especially for a normal distribution. Now, the other thing is the between, which looks a little bit tricky. Not. It is not. Think about it this way. You have this side and that side. And you just need this middle part. You don't need all of them. If you take, remember, if this whole thing is equals to 1, if I take this less than here, and I take this one here, and I subtract both of them from 1, what do I get? I get the orange. Right? If I subtract this white area here and this white area here, which this white area side is called A, it's called A, and this white area is called B. If I subtract A and B, I subtract them from 1, so I will get this shade. But I also don't have to do it that way, right? Easy, easy, easy. If I treat this B area as a standalone less than side and I subtract it from the A area, I will still be left with the B area. Why? This is easy. What do we need to do? Easy for cheesy, straightforward. We just need to go and subtract the value on the table for A minus the value, sorry, for B, because I'm going to use this portion instead of this one. I'm going to use this whole portion and subtract this. So this becomes my B and this becomes my A. So B includes this smaller portion, this one, this. That's B. It includes that and it also includes A. B is made up of orange plus A. Hence, if you want to remember this, hence we're going to subtract A so that we are left with B. So we're going to subtract A. So we're going to take away A again so that we can only report on how much is orange from that. So it means we are going to say the probability of Z, less than B minus the probability of Z less than A. So that we can only be left with that portion, this, this. Because our B starts from here to there. It includes this small one. So if this is B and this is A, what we need to subtract is just to be left with that. Take away A, and we will be left with this C nyana plot. That's what we're going to be doing. How do we do that? Easy. Straightforward. I'm going to use the same information so that then it doesn't become complex. So we know that the probability of X lies between 18 and 18.5 with a mean of 18 and the standard deviation of 5. What we didn't calculate is the probability of 18, or sorry, the Z-score of 18. So quick, I do calculate it. The Z-score of 18 will be 18 minus 18 because our mean is 18 divided by the standard deviation of 5 and the answer is 0. And remember, it is 0,00. Don't always just write the 0. Always remember to do it in 2 decimals so that you don't forget. This one we did calculate it before. It was 0,12. And we know that the Z-score lies between 0,00 and 0,12. Based on our definition, we said we're going to take the B value and subtract the B table value, subtract the A table value. So we go and do that. The B table value was 0,5478. And we subtract the A table value, which is 0,00, which is 0,50. And we get this small portion here, it is just 0,0478. This red shaded area. Easy. Any questions? Am I moving too fast? Is
Everything
it
is okay,
clear?
ma'am. Anyways, everything is clear.
Hi, ma'am.
Hi.
I joined the class late. Can will I later get like the full class, maybe a recording?
The recordings are always shared. I shared the link, but they take their sweet time with uploading. I see that they only had 2 recordings so far. Did you join based on the link I shared on the WhatsApp group?
No, ma'am, I'm not on the group, so that's why I was wondering if will I get this recording later on, or can I leave share my number so that I can be added on the group?
Let me add the WhatsApp group link.
Okay,
I
thank
don't
you
know
so
how
much,
to
ma'am.
get there. Right, now you see, you're reading all my. No, let me do it later so that
Okay.
because then
Okay,
my
thank you, ma'am.
yeah, I will have to stop the sharing and then do the WhatsApp link. Don't leave as yet, and then I will share it. Okay, so let's do exercises now. I want to skip all this so that we can now practice. We still have time. The session ends at 11. We have, how long do we have? Yeah, we still have 30 minutes. So in a nutshell, what I was trying to say, we've covered everything I said we will do, right? So we looked at the basic concepts. We covered some of them, not all of them, but some of them in detail. Some of them you still have to go and read more about the normal distribution. I've showed you that these values, probabilities, you find on the table. This ones, you say 1 minus the table value. So it means the value you find on the table, you subtract them from 1. This one, you're going to use the table value of B, subtract the table value of A, right? So table value and table value. Always remember, B, the second one minus the first one. Second one minus the first one. You always need to remember that you need to standardize your X values by using the formula. The formula stays the same for standardizing. Next week, when we do the sampling distribution, this formula will change a little bit slightly. The concept will still remain the same. So if you can master it this week, you can remember and know how to do it this week. Next week is going to be easy. Easy, because we're going to use the same. Nothing changes, actually. We're just gonna add one or two things, but nothing stays the same. The principle stays the same. Just a reminder, please, for any technical issue like the recording and all that, please send an email to CT and TAT. I will remind them to upload last week's session and this week's session. If you are struggling with your module content, you still unsure whether it's things that we've covered or you are way ahead and I'm still behind and you want some assistance, feel free to reach out to me. You have one-on-one consultation, 1 hour free consultations with me that enables us to discuss where you are stuck, what problems you need me to help you with, and so on and so forth. Do not hesitate to book those because I am available. I'm free, available anytime this time around. I don't have anything that is holding me back because I only have these classes now. Please do not forget to complete the register before you leave. And also at the end of the session, when you leave, remember to do the evaluation form. The link to both forms is pinned on the chat. I think you can, even if you join late or not, you will always find that links there. Please make sure you do that. My name is Elizabeth Boy. Okay, so next week we will be covering sampling distribution, which is similar to what we're doing. It's also a normal distribution session as well. Oh, I must still fix my slides. This is the exam prep. On the 12th of September, then we will be doing exam preparation. And I think there might be a couple of more sessions as well, depending on when the exam starts at UNISA. We might have some more sessions. So now let's look at exercises for this week. Which one of the following statement is incorrect? So it means you need to, one, have your tables open. You can find the table on your textbooks, in your study guide. I think in the study guide, they also do have it. You just need to know where in the study guide this table is on. So you need to have this table open so that you can answer these questions. So as you can see there, it says the Z is equals to, the Z is less than, and so on and so forth. But since it uses 0, so I'm gonna assume you need to change the 0 to 0, comma 0, 0, and the 1 to negative 1, comma 0, 0, and the 1 will be 1, comma 0. And I can just put remove the ink just to help those who don't have the table readily available. The problem is it only, for what I'm showing you, it only covers number 1, number 2, number 3, and okay, number 5, you don't even need the table. But you can continue. we are looking for let me see, the incorrect statement. So do a process of elimination. So maybe let's do it together, and then number 2, I will let you do it by yourself. So number 1, is that correct? The probability that Z is equals to 0. Okay, for number 1, it will be correct because remember these are cumulative probabilities, so we don't have a probability at a snapshot, but also a probability at that point will always be equals to 0. So number 1 is correct, but we're looking for the incorrect one, right? So the problem is when I type, my thing, it disappears. So I'm not longer going to write on the slide. Number 2, anyone who wants to take a guess whether is it correct or incorrect? Number 2, the probability of Z greater than 0.
That is correct, ma'am.
That is it
It
correct
is
or
correct.
incorrect?
It,
Is
it is
that what?
correct, ma'am.
It is correct because if you look at the probability of 0,00 is 0,5, and we know that it is the greater than, so therefore it means it's 1 minus 0,0, 0,5000, which is 0,5. And number 3, is it correct or incorrect?
It is correct as well.
It is correct because it's just that number that we see there on the screen. It's 0,0550. Going to number 4. Sorry, what did I do now? Number 4, I'll go to the negative side of the table so that then we can bring number, sorry, negative, it's at the top, not on this side. So we're looking for negative 1 comma, negative 1,00. We know that the first column is where the zeros are. So it is also correct. Number 5, is number 5 correct or incorrect? And can you identify why is it incorrect if it's incorrect? Okay, let me help. Remember, when we do the less than or equal, when we do that, we don't change. The A remains A. It cannot become B, right? The minute the value here changes to another number, therefore it means we're no longer talking about the same thing. So if you look at number 5, it says the probability that Z is greater than 1. So what should there be? It should say less than 1, right? So the answer here should have been, or the correct way of writing this one should have been 1 minus the probability that Z is less than or equals to what? Or something like that. Because I can see that they are using the less than or equal on this statement. But it cannot change because then this and this are not the same. They have to be the same. Same, 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 same. So your incorrect answer is number 5. So because you're also writing a multiple choice question, it means it's double the work. So as you can see that we had to go through 1, 2, 3, 4 before we get to the correct answer there. So you work double, you work triple, fourple, like yeah, more than you supposed to. So consider the standard normal distribution set. Which one of the following probabilities is incorrect? Now I'm not going to help you here. I can already foresee. Mm, eh, If you have the answer, you can also post it on the chat, or you can say it out loud and say the answer is option whatever the number. I'll give you some time. Open the so this one says it's negative 2.80. If I go there, 2.80, it is 0.026. And this one says it's 1 minus P of 2.8. So if, for example, just to test the logic, if this is 1 minus the probability of greater than 2.8, so therefore it means I can always test it and see if it's the same. So let's test it. So 1 minus the probability of Z greater than 2.8. What does that mean? It means it's 1 minus the probability of Z less than 2.8. You cannot just also assume. So, okay, here is the catch. What's the difference between what I'm doing now and this? It's because this was the less than and there it was the less than. They were the opposite, and that's why I could as automatically make an elimination with the number negative. On this one, this is greater than. It's not less than, because this side is greater than. It says the probability of Z greater than negative 2.8 is equals to, so it means it's the same as 1 minus the probability of Z greater than 2.8. So I need to test that. So 1 minus, and I need to go and find 2.8. So don't take it because the previous one we did it that way. It means it will also, the logic will also work on this. Is 2.8. So I need to go to the positive side. And I must look for 2.8. And there is no other number. Now it's 0. And I know that 0 is always the first one. So it's the first column. Oh, come on. So it's this first column. So that will be the value 0.9974. 0.9974. So, but while I'm still at it, what did I say this value is as well? So, because now I can go to my calculator, negative 2.8, I said it is. Negative 2.8 is 0.0026. So I said this is 0.0026. So let's see if we get the same. 1 minus 0.9974. It is 1 minus 0.0026, which is 1 minus 0.0026 is equals to 0.9974. Already I showed you using the process of elimination. You can do the next one. Is number 2 correct or incorrect? You have negative 2.10, which is 0.0179, and they say it's the same as the probability of Z greater than 2.1. So which means the value we're going to find on the table, we need to subtract it from 1. I like to always constantly write these values down, 0.0179. So this one is 0.0179. And this one will be 1 minus the value we find on the table. And that value would be positive 2.1, 0.9821, 0.9821. And what is that answer? Is it 0.17? In the exam, I would have found my incorrect answer and moved on, but because we are practicing, let's practice so that in case that was correct, then we need to move to the next one and see how we answer that. So that will be 1 minus 0.9821. And that is 0.0179. So that is correct. Can you see?
The incorrect
So
option, ma'am, is number 5.
there,
I was saying, ma'am, the incorrect option is number 5.
wait. So this is 0. So what is 2.1? 2.1 is 0.9821, and this is 0.500. So if I subtract those two, so 9. So this one will be 0.9821 subtract 0.500. I know that the probability of 0 is 0.5 because we've dealt with it in the activity before, and if I go here, you will see that it's 50% there. Come on, what am I doing? It's 50% there. So that is what I'm doing. Remember, this is in between. You take the second, subtract the first. And that would be, and that is equals to 0.4221. If you take that minus that. You can test it, you will see. Because 1 minus 0 is 1, and 2 minus 2 is 2, and 8 minus, am I calculating right? No. Oh, this should be 8. 0.4821. So they've got 2 questions that are incorrect. Because this is incorrect as well. Oh, sorry. I did it all wrong. Number 1. Sorry, my bad. I didn't take that into consideration, the sign. The sign says greater than. So this would be 1 minus that. So this will be also correct. Yes, you are right. Number 5 would be the incorrect one. I didn't take the greater than into consideration. And this one will be 0.5000. And this is negative 2.8 is 0.0026. You take this, subtract this, should give you 0.49. So you just say 0.5000, subtract 0.0026. We borrow 10, 4, 9 minus 2 is 7, 9 minus is 9, and 4 minus is 4. So that is correct. And on this one, we know that this is 0.0026 and 2.1. Did we get 2.1? 2.1, which is positive, is 0.9821. So we just say 0.9821 subtract 0.0026. 1, we borrow 11 minus 6 is 5. 1, we need to go and borrow from 8. 11 minus 2 is 9. And then here we have 7 and 9. So that is correct. So only number 5 is incorrect. You are right. And that's how you will solve. So there is a difference, as you can see. So you will need to be able to validate and test and check. Suppose that Z is normally distributed with the mean of 0 and the variance of 1. Which of the following statement is incorrect? So with this one, you have to go and say 1 minus the probability that Z is less than a value, 2.64. So it means you're going to say 1 minus the value you find on the table. What do we get on the table? 2.6. It's 2.6. But we need the 4. 4 is column number. Oh, sorry, my bad. 0, 1, 2, 3, 4. It is the last one on here. 0, 1, 2, 3, 4. So 2.6. It is 0.9954. 0.99. Did I write it correctly? Vice versa. 0.9959. 59. And that will be So I've done number 1 for you. Number 2 should be easy. It's just the value on the table. .87. So now with this one, I need to reduce this size. You need to go and find it. 8 is the second last. We're looking for 7. 7 is the third last. So this is negative. That's 7. Yes. So it means number 2 also it's correct. Oh, and then we can do number 3. I can give you the values. So the first thing you do is you look at the second, which is 1.4, and then you go to the positive side, 1.40. Then you take that number, 0.9192. Then you go to the negative side, and you do the same, negative 1.40, which is 0.0808. Take those two numbers. So you will take those two numbers, subtract. Get on this side. 9192. 0.9192 subtract 0.0808. And see if you get the answer. Point 9192 subtract 0.0808, which is correct. That is correct. Then you go to number 4. She's in the negative. And we're looking for 2.8 and 0, which is Bob is your answer. There is your answer. Bob's your angle. Oh no, what happened?
Option 4 is incorrect, ma'am.
Option 4 is the incorrect one. Option 5. Gosh. Option 5. So option 5 can also confuse you if you don't pay attention. As long as here they didn't put 1 minus, so it means you go and find the value here, which is 1 minus the probability of Z less than 0.74, and go and check if that value you get here is the same as that value, which then takes us to, I don't know why my table is behaving like this. My PDF, it says the PDF contains unapplied reduction. I don't do, okay, let me redo. So 1 minus 0, comma, so we go to the positive side. Come on, really? You go to the positive side and look for 0, 0.74, which is 1 minus 0, 0.77. 1 minus 0, 0.7704, which is 0, 0.2296. Then you go to the negative side and see if negative 0, 0.7, I must also go up. And they are the same. 1 minus 0, 0.7704, it is 0, 0.2296. So it's also the same. So this is 0, 0.2296 and this is 0, 0.2296. So only option 4 is incorrect. I want to skip some of the activity, but you can do them. I've shared the slides on the WhatsApp group. Those who are going to join later, then I will share with you the the slides with you as well. Don't put your cell phone numbers on the chat. Okay, so here is one exercise. It looks like this. So they're asking you to find the area underneath the curve. So already this has standardized the value. So you take this minus that. So you go to find the table value, subtract the table value from 0, 0.00 table value, and that will give you the answer you are looking for. You can take a screenshot and do it. This one, they want you first calculate Z. Sorry, it says greater than. Oh, sorry. It's greater than, so it's greater than x minus the mean divide. That's what you are calculating. So therefore, it means you're going to say 1 minus the probability of Z less than x minus the mean divided by the standard deviation. I'm doing it this way so that then you just substitute into that, because then when you get to the answer, you will get Z less than a value, and then you go and find that Z value and you subtract it from 1. That's the principle. So your standard deviation is 20, your mean is 100, and your X is 145. So you just substitute there, 145 minus 100 divided by 20. And then you will get 1 minus the probability of Z less than, and then you get the answer, and then you go to the table and find the table probability value. Then this one, what are they saying? Easy for cheesy. They are saying the probability of x less than a is this. So what you need to do is you can either go backwards to go and calculate, because that's what they want you to calculate, to go and calculate the value. I don't know what value they want you to calculate, the value of A. So we work backwards because we need to go and find the Z value. So you go and look for this. I'm going to show you. You go to the table. Sorry. You go to the table. You look for 0.1515 inside the table. So it will always be on the negative side, because the negative side has smaller values. 0.15, those are 130, 112, 147, 1515. There. You do two things. You go out to the left. That is Z is minus 1. Oh, what did I see now? What did I do? See, 1.0. You go up, that's 3. So that will be 1.03. I know what my Z is. Now, easy. Remember the formula is Z, X minus the mean divided by the standard deviation. Your X is the same as the A there. So what you do is, because this was less than, that's why I found the Z value easy. If it was greater than, I will have said 1 minus this value so that I can get the actual Z value. So I just substitute minus 1.03 is equals to A minus our mean is 30. Pay attention, variance. Standard deviation is the square root of your variance. So therefore, it means this is the square root of 16, which is equals to 4. And 4 times minus 1.03 equals A minus 30. Therefore, this is the same as whatever the answer here would be. What is 4 times? Now I'm taking time. Negative 1.03 times 4 is negative 4.12, and you add 30 to it, and that you will get the answer. I'm not going to do the entire equation for you. So 30 minus 4 you will know what the answer is. So I was just showing you. And the same as with this one, it says the area to the right. So it means this area is 0.26 or 2061. That's what they say. The area to the right. Choose which one is the correct answer. They just want to know what is the Z value there. The area to the right, how do we find it? It's 1 minus 0.2061. So you will find the answer there, and then you go to the table and find this answer. I'm just gonna call it the question mark. You're gonna go and find the question mark and then go out and find those two values and find what the value is. I hope you understand what I'm saying, because I'm rushing everything right now. So area to the right, you find it this side. We know that that will be the greater than, the greater sign, right? If it's area to the right. We know the table contains only less than, so that is why we're subtracting it from 1. We get the answer after we subtract the probability. This probability they gave us from 1. And that probability, we go inside the table. We go look for it inside the table, like I did with this one. You find that probability somewhere in here. You go up, you go out. It can be depending. Let me see how big is the value. So this is 0.2. So it will be on the positive side, because you can see this is smaller numbers. So it will be 8 point something or 7 point something or 9 point something. You will find it here. Then you go out and you find the Z, the first two values, and then you go up, you get the last value, and then that will give you what the answer would be. I don't know the answer there because I didn't calculate it throughout. This one, same. They give you the Z value, right? And nothing about greater than or equal, but what they're asking you is to calculate. You do the same as this. You do the same as this because they're asking you to find X. So that is it. X, that's what they need you to calculate, minus the mean divided by the standard deviation. They gave you your Z, they gave you your mean, they gave you your standard deviation. Substitute, find X. I've showed you how to do that. This one is the normal one. They're asking you to find the probability of X is greater than 35 or 3.5. Easy to find because you just need to find the probability that Z, you standardize this value. Z is less than your X minus, your X is 3.5 minus the mean divided by the standard deviation. You just substitute the values, which is 3.5 minus 10 divided by the variance. Variance, you need to find the square root of 9, which is equals to 3. So divide by 3, and you find the probability of Z less than the value, and you just go to the table, and the answer, or any one of this, will be one of them. You will find the answer there. I'm not going to give you the answer. I'm just giving you the hint in terms of how you will tackle the question. I'm not going to go through all of them. You will go and sort it out yourselves. On that note, I'm going to conclude right here and say thank you for joining the session. Remember, any consultation, you can book it with me. Don't forget to sign the register. Don't forget to do the evaluation. My name is Elizabeth Boy. I will see you next week when we do sampling distribution from 9 until 11. That will be on the 22nd. On that note, are there any questions?
No question from my side.
Let me share the link to the group chat. How do we share this thing?
I've already shared it.
Oh, you already shared it. Oh, thank you. Thank you, thank you, thank you. Oh, I can see you already joined as well. What I will do is I will resend everything again to you. Don't worry. I will resend them on the group chat. Those who receive them, they will still receive them again. Yeah, other than that, have a lovely, lovely Saturday weekend until next week. Bye.
Bye, April. Enjoy the rest of your week.
Yeah, thanks, man.